prime factors. You need to get your writing materials.
Get them now.
We'll meet in class. Welcome. Just before we start the class, there is an exercise for this work. So I want you to engage with the exercises immediately after the class. You're going to enjoy those questions. They are exercises on this very topic. You'll find it simple. Alright, what are prime numbers? Prime numbers are a set of numbers that have their factors to be one and themselves only. What does this mean? This means that they can only be divided by one and themselves without remainder. So prime factors are a set of numbers that can only be divided by one and themselves without any remainder. We take a look at example of prime numbers. And when I say prime numbers or prime factors, they actually mean the same thing. Okay, the first number in that category is not 1. The first number in that category is 2. After 2 is 3. After 3 is 5. After 5 is 7. After 7, 11. After 11, 13. After 13 is 17, 19, 23, 29, 31, and 37. Again, 2, 3, 5, 7, 9 is not a prime number, okay? 3 divides 9. 3 times without remainder. 11, 13, 17, 19, 21 is not a prime number, okay? It's just an odd number that cannot be divided by 2. 3 divides 21, 7 times without remainder. Next number there is 23. Next here is 29, not 27. 27 is not a prime number. 27 is divided by 3, 9 times. Then we have 29, 31, and 37. So we're going to be limiting ourselves. Then this range of number from 1 to 40. So this set of numbers are the prime numbers we have in between 1 and 40. We'll take a few examples. We want to express some numbers as a product of prime numbers. So we'll be expressing 12 as product of prime factors or prime numbers. We're expressing 18 as product of prime factors or prime numbers. We're going to be expressing 24 as product of prime factors. Okay, so here we go. We have a solution here, and the first thing we have here is the set of numbers we highlighted in the previous page. So the first thing is we want to express 12 as a product of prime numbers or prime factors. So we'll draw this tree around 12. Again, you come here and pick the list of these numbers that will divide 12 without remainder. I said that again. You come here and select the list of this set of numbers highlighted here that will divide 12 without remainder, and that number is 2. Okay, 2 is the number, the least, that will divide 12 without remainder. So we'll pick 2 here and we'll divide 12 by the 2, and our answer is 6. Okay, we'll come here again, we'll pick the list of these numbers that will divide 6 this time around without remainder. Not 12 again, but 6 this time around without remainder. It is still 2. 2 still divides 6 without remainder, and it's still the least here. So we'll pick 2, and when we divide 6 by 2, we have 3. And this time around, we are working on 3. We come here and we'll pick the list of this set of numbers that will divide this 3 without remainder, and that is 3 itself. Why? 2 will not divide 3, otherwise there will be remainder. But 3 divides 3 without remainder, so we'll make use of 3 itself, and we'll use it here. Okay, so we divide this 3 by the 3 we bring in here. We'll divide this 3 by the 3 we bring in here, and we have 1. Okay, so until we have this quotient that is 1, we will not stop. Now that we have 1, we can stop. Now the next thing is we'll bring out all the factors we have here in this column, and we'll multiply them out. The first 2 multiplied by the second 2, then multiplied by the only 3. We are multiplying every factors that we have here. Everything still equal to 12 that we are working on. Okay, now this is 2 multiplied by 2 multiplied by 3 equals 12. So with what we have on this side, that is expressing 12 as a product of prime factors. Now your question will necessitate you to express them in index form. So how do you go about that? In index form, you have 2 appearing 2 times in the multiplication here. So that is going to be 2 raised to the power of 2, then multiplied by the only 3. Okay, so it's still the same thing, but you are expressing this in index form. So this 2 raised to the power of 2 multiplied by 3, and we still have our 12. So this is 12 expressed as a product of prime factors. and here is still as a product of prime factors but in index form. All right, I hope that is understood. So we'll move to the next question. B, we want to express 18 as a product of prime factors. So we'll draw the same tree around 18, and we'll come here again and pick the list of these numbers that will divide 18 without remainder, and the list of them is 2. If 2 divides 18, 9. The next number in this category that will divide 9 without remainder is what we'll be working with now, and that number is 3. Why? 2 cannot divide 9, otherwise it will remain. Say 9 now divided by 3, so you have 3 itself. Come here again and you pick the list of these that will divide 3 without remainder, and that is 3 itself. So 3 divided by 3, that is going to be 1. Until where we can have 1 as our answer, we won't stop. We'll stop here and write out all the factors that we have on this side. So here we have 2 multiplied by 3 multiplied by 3, and that's going to be 2 times 3 times 3, still equal to 18. Now come down here and expressing it in index form. Expressing it in index form, that's going to be 2 multiplied by, now we are having 3 2 times in the multiplication here. So that's going to be 3 raised to the power of 2. Okay, so this is expressing 18 as a product of prime factors in index form. We want to express 24 as a product of prime factors. Just like we'll pick the list of the set of numbers the other time. So the list there is 2. I want to suggest that for you to do any work regards prime numbers like this, please do have the list of those numbers, just like I have it in the previous page. Do have the list of those numbers. So we have 2 now. Now divide 24 by 2, 12. 12 now divided by, the next number is going to be 2. Divide 12 by 2, we have 6. 2 is still functional. Okay, now we divide 6 by 2, we have 3. Now we make use of 3. Why? 2 is no more functional. 3 now divided by 3, we have 1. So we'll stop here. Now we write out all the factors we have here. That's going to be 2 multiplied by 2 multiplied by 2, then multiplied by 3. Okay, so we still have our 24. Right now I want to express this in index form. This is in ordinary form. Of course, this is our answer, but in case you are told to express them in index form, then that's going to be 2 raised to the power of, how many times do we have 2 here? That is 3 times. 2 raised to the power of 3, then multiplied by the only 3 that we have here. Everything is still equal to 24. Here is the index form of expressing 24 as product of prime factors. Okay, now we'll look into more examples. We want to express more numbers as a product of prime factors. So here we're going to be expressing 40, 75, 81, 225 as product of prime factors. So we'll move to the next page now. So a solution. We'll work with 40. Okay, now we'll make use of 2. 2 is the list of the prime numbers that will divide 40 with a remainder. So divide 40 by 2, we have 20. 2 is still functional. Divide 20 by these 2, our answer is 10. 2 is still functional, so we'll make use of 2 here. So you divide 10 here by these 2, you have 5. Okay, now 3 is no more functional. We'll go for the prime factors, the list of them that will divide 5 without remainder, and that is 5 itself. 5 divided by 5 is 1. So here we stop, and we express all our numbers here outside. That's going to be 2 multiplied by 2 multiplied by 2 multiplied by 5, all equals 40. Expressing it in index form, 2 raised to the power of 3. We have 2 3 times here in this multiplication. So that's going to be 2 raised to the power of 3 multiplied by 5 equals to 40. Understood? Next, we'll work with 75. We'll go for the list of our prime numbers that will divide 75 without remainder. Now 2 will not start it. Why? 75 cannot be divided by 2. There will be a remainder. Okay, so we'll make use of 3 this time around. So 75 now divided by 3, that is 25. Next, we'll make use of 5. We'll make use of 5. 25 divided by 5, that is 5 itself. Next, we'll make use of 5. 5 divided by 5, that is 1. Now we'll stop since we have 1 here. So we'll write out everything here in this column. That is going to be 3 multiplied by 5 multiplied by 5 equal to 75. So this is our answer, 3 multiplied by 5 multiplied by 5. Now in index form, okay, it's going to be 3 now multiplied by, we have 5 appearing 2 times, okay? That is going to be 3 multiplied by 5 raised to the power of 2. So everything is still equal to 75. So this is our answer in index form. Understood? Now, C. We want to express 81 as a product of prime factors. How do we go about that? 2 will not divide 81, otherwise there will be remainder. You make use of 3. Now you divide 81 by 3. We have 27. 3 is still working. 27 divided by 3, that is 9. Now you come here again, make use of 3. 9 divided by 3, our answer is 3. So it looks like we're using 3 all through here. Make use of 3 again, divided by 3, that is going to be 1. So writing out everything we have here, that is 3 multiplied by 3 multiplied by 3 multiplied by 3, that is 81. Now in index form, we are having 3 all through 4 times. So that is going to be 3 raised to the power of 4 equals 81. So expressing 81 as a product of prime factors in index form, our answer is 3 raised to the power of 4. Hope that is understood. And the last example here before we bring this class to an end, we want to express 225 as a product of prime factors. So we'll make use of 3 again. 225 divided by 3, 75. So making use of our 3, 75 divided by 3, 25. Now 3 doesn't work again, but 5 does. So 25 divided by 5, that is 5 itself. Now we'll make use of 5 here as our factor, okay? Now, so 5 now divided by 5, that is 1. So here we'll stop. And we'll write out how that we have here. Here our answer is 3 multiplied by 3 multiplied by 5 multiplied by 5 equal to 225. Now in index form, 3 raised to the power of 2, then multiplied by 5 raised to the power of 2. So that is equal to 225. Here comes the end of the lesson. Hope you enjoyed the lesson. I believe all we've done is understood. If you have any questions, do post it in the comment section. And if you have challenge in any of your topics in mathematics, just let me know in the comment box. Remember, I said in the beginning of this class that there's going to be a question. So the link is in the description box below. Attempt those questions. They're just few. You're going to enjoy them. This will help you evaluate yourself if you understand this topic very well or not. Hope you enjoy the lesson. If you like it, why don't you give it a thumb up by clicking on the like button, and more so to subscribe to this channel. This will help us a lot to reach you better, to serve you better, and to improve us. And maybe you love being engaged in an online tutorial. I'm going to share my link how you can reach me in the description box below. Just give me a call or text message. And do not forget to subscribe to this channel. Do share it with people, friends that you know will benefit from the content that we teach here on this channel. See you again next time. Goodbye.